Looking at the clavicle from above, we can see that it's slightly S-shaped, with a forward curve to its medial half. At its medial end, this large joint surface articulates with the sternum. At the lateral end, this smaller surface articulates with the scapula. On the underside, massive ligaments are attached, here laterally and here medially. The scapula is a much more complicated bone. The flat part, or blade, is roughly triangular, with an upper border, a lateral border, and a medial border. The blade isn't really flat. It's a little curved to fit the curve of the chest wall. This smooth concave surface is the glenoid fossa. It's the articular surface for the shoulder joint. Above and below the glenoid fossa are the supraglenoid tubercle and the infraglenoid tubercle, where two tendons are attached, as we'll see. A prominent bony ridge, the spine of the scapula, arises from the dorsal surface and divides it into the supraspinous fossa and the infraspinous fossa. At its lateral end, the spine gives rise to this flat angulated projection, the acromion, which stands completely clear of the bone. The clavicle articulates with the scapula here at the tip of the acromion. This other projection, looking like a bent finger, is the coracoid. Now let's look at the shoulder joint. To understand the shoulder joint, let's get acquainted with the upper half of the humerus. This is the head of the humerus. The articular surface is half of a sphere. On the anterior aspect is a well-marked groove, known as the bicipital groove, because the tendon of the long head of the biceps runs in it. At the proximal end of the groove are the lesser tubercle and the greater tubercle. Because it's between two tubercles, the bicipital groove is also known as the intertubercular groove. Down here on the lateral aspect of the humerus, almost halfway down the bone, is a rough spot. Now let's look at the bones, starting with the humerus. We've looked at its proximal end already. Now let's see the distal end. It's flattened from front to back, with a complicated articular surface and two prominent lumps, the medial epicondyle and the lateral epicondyle. These are major muscle origins, as we'll see. Above each epicondyle is a ridge, the epicondylar ridge. Here's the lateral one. The articular surface is in two parts. The pulley-like trochlea articulates with the ulna. The rounded capitulum articulates with the radius. Now we'll add the radius and the ulna to the picture. The big hollow on the back of the humerus, the olecranon fossa, accommodates the end of the ulna, the olecranon, in full extension. Now let's look at the two forearm bones, the radius and the ulna. They're different in that the ulna is bigger proximally, the radius is bigger distally. They're also different in that the radius rotates, the ulna doesn't. The two proximal ends of the radius and the ulna. We'll look at the ulna first. The main feature of the proximal end of the ulna is this large curved articular surface. The curve that it forms is called the trochlear notch. It articulates with the trochlea of the humerus. The very proximal end of the ulna is the olecranon. The triceps tendon is attached to it. This projection is the coronoid process. Distal to it, this rough area, the ulnar tuberosity, marks the insertion of the brachialis tendon. This small curved surface, the radial notch, is where the head of the radius articulates. This is the head of the radius. This is the neck. The end of the head articulates with the capitulum of the humerus. Its curved side articulates partly with the radial notch of the ulna and partly with the ligament that surrounds it, as we'll see. Just distal to the neck is the radial tube, shortly the triangular fibrocartilage. The pointed tip of the ulna is called the ulnar styloid. The broad distal end of the radius has two articular surfaces. This large one articulates with the proximal row of carpal bones. This small surface articulates with the ulna. This point is the radial styloid, the radiocarpal joint and the midcarpal joint. To understand them, let's look at the bones. We'll look at them this way up. 8 small carpal bones form the carpus. Distal to the carpus are the metacarpal bones, numbered 1, 2, 3, 4, and 5. The carpal bones are in 2 rows, a proximal and a distal. The bones in each row are attached closely to one another. The 4 bones of the proximal row are the scaphoid, the lunate, the triquetral, and the pisiform, which sits by itself on the triquetral. The scaphoid, the lunate, and part of the triquetral articulate with the distal end of the radius to form the radiocarpal joint. The distal surface of the proximal row forms a deeply concave notch which the bones of the distal row fit into. The bones of the distal row are the trapezium, the trapezoid, the capitate, and the hamate. The capitate and part of the hamate project proximally. The bases of the 5 metacarpals articulate with the distal row of carpal bones. The first, the one for the thumb, articulates by itself with the trapezium. The other 4 articulates in a row here. The distal row of carpal bones articulates with the proximal row here to form the midcarpal joint. The projecting capitate and hamate fit into the notch in the proximal row. When flexion and extension occur at the wrist, the movement happens partly at the radiocarpal joint and partly at the midcarpal joint. When radial deviation and ulnar deviation occur, the action happens mainly at the radiocarpal.